Alright, so the next piecewise, if you see here, it's -5. That's a horizontal line. So you should only go from -9 to -1 and just make a horizontal line. That's it. Alright, the next one is a radical. And what I did is I plugged in values from -1 to 3. So from -1, I just plugged in -1. I got 0. Square root of 0 is 0. It gave me the point -1, 0. That's your y value. That's your x. Then I plugged in 0 and got 1. The square root of 1 is 1, so that's 0, 1. Then I plugged in 1 and got the square root of 2. That didn't really give me a point, so I didn't use that. Plugged in 2, that gave me square root of 3. That didn't give me a point. I didn't use that. And then I plugged in 3, got the square root of 4, which is a perfect square, gave me 2, so I have the point 3, 2. So I was able to plot these 3 points right here. Now I curved it, because remember, your root graphs are curves. They always start like this and curve up, so make sure that you curve those. Okay, the last one, I was a little ambitious. You really just have to plug in 3 and plug in 7. So I don't know why I plugged in all of those numbers. But if you plug in 3, you get the point 3, -2. And then you get the point 7, 6. And you see that the slope is 2, so you can just go up 2 over 1, up 2 over 1, etc. So you really should just, for linears at least, plug in 3 and plug in 7. If you wanted to plug them all in, that's fine, and get the answer. Alright, so I'll give you a second to look at that. Alright, the next one is writing piecewise equations. So the writing piecewise, I looked here, it had a slope of -2. Okay, because the slope went down 2 over 1. So that's where that -2 came from. And then what I did is I just continued it. And that is where my graph would cross the y-axis if it were to continue. But it doesn't continue. But that's where this number comes from. Okay, the next one is just a horizontal line at 1. So all you have to do is put 1, nothing else. Okay, the last one is a absolute value. So you know it's a V. All V graphs have a vertex. So this one has a vertex at 5, -1, which means that you moved right 5 and down 1. And this was your vertical stretch by a factor of 2. Because that was our slope on the right hand side. So here's my vertical stretch. Here's me moving right 5 and down 1. Now these are your domain restrictions. This line represents x equals -7 and x equals -3. So these are how far apart the graph is going to be. And I put lines underneath both of these because both of these areas of the domain were colored in. And these 3 I just colored in myself. They were not originally colored. Okay. Okay, so the next one at here was x equals 3. This graph goes to the right of 3 and then keeps going on forever. So that's why this has x is less than 3, but an open circle means you have no line. Alright, the next one was all linear, 3 linear functions. So the slope I saw here was going up 3 over 1. So because of that, it's a vertical stretch by a factor of 3. That's why there's a 3 there. I decided to continue going up 3 over 1 to see where would the graph cross the y-axis if it were to continue, and it crosses at 9. So that's how I got that second number. Alright, here you can clearly see that it goes down 1 over 1. So that's how I have -x. It's a reflection because instead of the graph going this way, it goes this way. And it started here down 5 because it goes through the y-axis at -5. Now the last one goes up 1 over 3. So this is a vertical stretch by a factor of 1/3. It goes up 1 over 3. And so I decided to continue it to see, okay, where would it cross the y-axis if it ever did? And it would have crossed at -2. Okay, so there you go. Alright, this page I had done all of them, but you know, the video got erased, so here is the answers to number 17. Oh, yeah. So this is 17's answer. I know it looks like a big old mess. This is the answer to number 19. And then I have the answer to number 20. It's all here. So in this little tiny space here, I'm going to write the answer to number 18 because I had erased it because I ran out of room. Okay, remember, always write it in terms of y. Then you're going to switch the x and y. Get rid of that 7. And now the only way to get rid of that root is to square it. So now to finish it off, you're going to subtract 10. And you're left with y equals x plus 7 squared minus 10. Now we went from a root. Roots have a domain that starts at -10, goes to infinity, because we just take the opposite of what's inside this root. And the range will go from -7 to infinity because that's the second number. Quadratics always have a domain of all real numbers. Okay, all real numbers for the domain, but the range goes from the lowest point to the highest point. So it looks like your domain and range switch from quadratics to roots. Alright, so I'll give you all a second to copy this all. It's a lot of information, so I'll try to go over as much as I can in class. Alright, these are the types of discontinuity. So we just have infinite here, jump here, and then point there. That's it. Alright, rational functions. These are rational functions, and they have two types of asymptotes. So I know in class I showed you one asymptote, which is just taking the denominator and setting it equal to 0. But you have to get the other asymptote as well. The other asymptote comes from dividing your coefficients of x if the powers are the same. If the powers aren't the same, it's a different procedure, and I'll show you that tomorrow if I can. Okay, so x would equal -7/3. That would be an asymptote and an area of discontinuity. And then y equals 2/3 would be the other area of discontinuity because that's a horizontal asymptote. X equals -17 is a vertical asymptote, so that's an area of discontinuity. And then just dividing 3 divided by 1 gives you 3. So that's a horizontal asymptote at 3, so that's the other area of discontinuity. Okay, the last two questions were just looking at taking what's underneath and bringing it up. So I like to always get the points. So if you get the points, it makes it a lot easier. So I took this point, moved it up, took this point, moved it up, took that arrow, moved it up. So, and that's how I was able to come up with this picture. These 4 points here come from this point, this point, this point, and this point. So once you have your 4 or whatever number main points, you just put them all there. So you know this arrow is going down, so now it should go up. This line is going down, so it should go up. This line is down, it should come up. These are already up, so they'll stay up. These are down, so they should come up, and then this stays up. Okay, last one only had one section that was underneath, and the real interesting thing that is you have a straight line here, so it's just going to come up and just be another straight line. This line is going to come up here, and then this will stay in this direction because it's okay to come down as long as you're not underneath the axis. And then this little piece here will come up. So I extended it a little bit more. But the main points were this one, this one, this one, and this one, which was a little bit off the graph. Once you have those points, keep everything that's up, up, and just take everything that's down and bring it up. Alright, that ends it. So, let's party a little bit and enjoy and relax and study. Alright, good luck everybody. I know that this video is probably not as extensive as you'd want it to be, but I tried, but the last video got erased, so I left all the answers, so hopefully this will help. Remember, I am here Thursday, and if you are in dire need of me Friday, I will help you then as well. Alright guys, good luck.